Okay. Let's go ahead and talk about your board problem. We're kind of running out of time, so I want to go ahead and just go over this with you. And so if you want to have those notes from the other day and you want to kind of jot a couple things down, you can. So number one, I'm always going to find the midline first, just because it makes my life easier later. So here's my midline right there. I'm just going to jot down, you don't have to do this, but I find it to be helpful. I go ahead and jot down the midline equation. That's at -2. And then I'm going to examine what happens at angle 0. And if I'm looking at this, it begins at the midline. And so I know it's sine. So I know that this is the sine function. And the second thing I'm going to notice is that I know that sine usually starts at 0 and goes up. But this one actually starts at 0 and goes down. So that immediately tells me that there is a reflection over the x-axis. Okay. The amplitude for this is 4. The period for this is 1 full cycle of the wave is going to be from 0 to 6 pi. That's my period. There's no phase shift. Midline is at 0, right? So this little place here. And then to find the period change, in your notes from yesterday, you saw that 2 pi divided by b gives us the period. So now instead of like being given b or being able to look at the equation and extract b from the equation, we're working backwards. Because what you actually have here, so this is the relation, right? But what you actually have by looking at the graph is you have the period. It's 6 pi. And so we need to solve this equation, right? And we're going to pretend like this is a variable just like x. And what you need to understand about pi is that it's just a number. And so it's going to behave like any other number. So really in your mind, what we are solving is something that just to make something that's similar up, you're actually going to solve something like this, right? This is the version of it that you've probably seen before. And so in this case, we're going to multiply both sides by x. We'll end up with 4 equals 6x. We'll divide both sides by the coefficient of the variable we are attempting to isolate. And you'll end up with 2/3 for x. Okay? So we're going to do the same thing here. I'm going to multiply both sides by b to eliminate that. The next thing I end up with is 2 pi equals 6 pi b. And if you remember that your variable is b, you're trying to isolate b. So in order to do that, we are going to divide both sides by everything that is not b, right? So this is just a number. I can treat it like 1. So here the pi's cancel out, and you'll end up with 1/3 as your value for b. 1/3. Okay. So when we're writing an equation, if you remember, we have y equals a sine b x minus c plus d. And so, well, what is a? Well, a is -4 because it's an amplitude of 4 with an x-axis reflection. B, we already obtained. We know that's 1/3. C is 0 because there's no phase shift, so there's no shifting left to right. And D is the midline. That's at -2. And so now I'm just going to plug all of those numbers directly in. So we'll have y equals -4 sine b x minus 0 minus 2. So it's not really necessary to have this -0 here, right? So you can put it there or not. I'm okay with either one, really. We don't have a paper. I'm just going over the board problems. And then we'll get a paper in just a second. I'm gonna do several examples before I let you practice on your own. All right, so there's a lot of information here. Completing the CYU last night would help you kind of access this a little bit better. So what I'm going to do while you're making any necessary notes or additions to what you have currently, I'm going to give you the examples for today. And then we will get started. So I'm just going to do a bunch of examples with you because I already have given you all the information that you need. But they're, it's going to be helpful, but it's pretty complicated at first. So the trick here is to learn exactly how to analytically look at these graphs. Don't just look at them. You have to specifically look for very, very detailed things in a certain way. And I've already kind of given you some of that information of how to do that. I'm looking for a cycle. I'm looking for a midline. I'm looking for this, that, or the other. The distance between two peaks or one full cycle. So there's a lot of different ways to look at it and think about it. So I'm going to do these with you. Okay, let me get my zooming in correct. All right. So at the top of this particular task, I've written the general format for both the sine and cosine functions as we transform them. A cosine bx minus c plus d, and then the sine counterpart over there. So I give you a graph, and you're going to write me the equation. But there's a very specific way I need to go about analyzing this graph. And along the bottom is the order I like to go in. So the first thing I'm going to do is I'm going to find that midline. So the midline is going to be here. And so if you think you've got the midline and you want to double check, you need to make sure that the distance from the midline to the top is the same as the distance from the midline to the bottom. All right, so the amplitude here we are at currently y equals 1. And the max is at 3, and the min is at -1. So I'm 2 units away. So my amplitude is 2. The equation of the midline we've already established is y equals 1. This is sine of x. It starts at the midline and goes up for its cycle, so there's not going to be any sort of reflection over the axis, right? And now let's examine the period. So we begin here at the midline. We will make one full cycle up, down, and back up. And so this is where the period ends. That's one full cycle in between those 2 points that I've drawn. And so the period for this function is going to be pi. So in order to find the equation for the sinusoidal function, I'm going to need the parameters a, b, c, and d. Right, so a is given by the amplitude and the reflection. So in this case, a equals 2. The midline gives us d, which is 1. There is no phase shift, so we just don't worry about c, okay? We'll write c as 0. And then the period is calculated with the following relation. The period is 2 pi divided by the parameter b equals the period that is observed, right? So now I have this same equation that I was working with before. So I'm just going to move across here. So this will be, we're going to multiply both sides by b. I'll have 2 pi equals pi times b. And then I'm going to divide both sides by pi. So then I'll have 2 pi over pi equals b. That cancels. And so b equals 2. And so I'm just going to come back and I'm going to write that right up here just to stay organized. You can write it wherever you want to. And then I'll make a note here for myself that there's no phase shift. And that means that c equals 0. So now I will go back and I will just write the equation. So I've determined that this was sine 2, sine b is also 2. So that's 2 times x minus 0 plus 1. So I have A, B, C, and D. And I've pulled all of those values off the graph. All right, moving on to the next one. I'm going to blow this graph up just a little bit so we can see it. Here we go. So the first thing I'm going to do is I'm going to draw in my midline. Midline is going to be here. That's going to be y equals 1. This function goes up by a half and down by a half. Right? It doesn't quite go from 1 to 2, so that's 1/2. I'm just going to write this stuff up here so we can see it. So the amplitude is 1/2. This is the cosine function. I know that because at angle 0, we are at a maximum value. And that also means cosine is not reflected because cosine should begin at 1, positive 1. Okay, so I know that cosine is not reflected. So I'll make a note of that here. No reflection. The midline equation, y equals 1. And now I just need to get, some information about the period. So the period, by the way, is not b. B is the number in the equation that corresponds to the period. So starting at 0, it's this point, and for one full cycle of cosine, we'll end here. And so the period here is 2 pi over 3. And we'll need to, now let's see if we can get A, B, C, and D. Amplitude, 1/2. There's no reflection. There's no phase shift. C equals 0. No phase shift. That's D. So I've got A, B. Now I've got A, C, and D. So now I need B. So I'm going to say, okay, 2 pi divided by B equals the actual period here, right? Okay. So we're going to multiply both sides by B. That's going to cancel out. I'm going to end up with 2 pi is equal to 2 pi over 3 times B. So the good news here is you have a calculator that will divide fractions for you. So I'm going to say 2 pi divided by 2 pi over 3 is going to give me my value for B. That's going to be, I think it's just 3. Y'all double check. Yeah, okay. All right, so B is 3. All right, so I've got, mine's a little less organized just because I wanted to zoom in enough, right? So here's my A, here is B, here is C, here is D. And I should be able just to plug things in to get an equation now. And we determined that this was cosine. So this will be 1/2 cosine 3 x minus 0 plus 1. A, B, C, D. Okay, let's do another one. Again, I'm going to leave the graph large here so we can see it on the projector. If you want to fill out the little boxes, keep yourself organized, that's a great idea. Let's talk about the midline for this function. Here it is. I'm gonna go ahead and write the equation for the midline right here. This is y equals, looks like that's -1. Amplitude, we go up from -1 to 2. So we've got an amplitude of 3. If I'm looking at this point right here, at angle 0 on the x-axis, we are in the midline. So this is sine. However, sine should go up from the midline, and it doesn't. So it is reflected over the x-axis. There's no phase shift. Now let's figure out the period. So for sine, we begin at the midline, we go down and back up, and then we go up and back down, and we arrive at the end of one full cycle. This is the period, which is pi radians. All right, so A equals -3. We account for the reflection and the amplitude in A. Okay, Braylon, wake up, baby. This is D. This is C, which is 0 because there's no phase shift. And to find the period, we're going to say 2 pi over B equals pi. And then we're going to multiply both sides by B, so I'll end up with pi times B. I'm going to divide both sides by pi, and I'm going to end up with B equals 2. So I've got A, B, C, and D. Yes?
Okay, you might have said this, but I missed it. But why is the amplitude negative?
The amplitude is negative.
Because it flips?
Yes.
Okay.
The amplitude is never negative.
That's what I thought.
The A value
Okay.
addresses both the amplitude and if there is a reflection. Okay, so both of those are combined into the value for A. Okay. So now writing the equation, we will have y equals -3 sine 2x minus 0 minus 1. Other questions so far? It's a lot to look at. All right, example number 4. I'm just going to write all over it again so we can keep this, okay? So let's write the midline. The midline is right there. Midline equation is going to be y equals -2.5. I'm halfway between 2 and 3. Looks like at angle 0, we are at the midline. Yes. If it was 1.5, it would be right here. That's a good question, though. If it was between 1 and 2, it would be. But we come down, we go to 1, 2, a little over 2, and not quite to 3, so it's 2.5. We notice here that this is the sine function. It starts at the midline, but sine normally goes up from the midline, but it does not. It goes down. So we are reflected over the x-axis. You gotta remember that. And we have an amplitude. Let's look. So the midline is at 2.5 all the way up to -1, so I go 1.5 units, so the amplitude is 1.5. The sine wave cycles by going down, up, and back down, and so the period ends here. So our period is pi. There's no phase shift. Notice I'm doing this in the exact same order every single time. Doing it in this order makes it easier to find all the features. You do not have to do it in this order. I just find it to be easier if you do. And again, this is sine x. Right, so A is going to be given by these two things. So A is negative 1.5 to account for the reflection. Phase shift gives us C, there is none, so the shift left and right is 0. The midline gives us D, the vertical translation, so the D value here is negative 2.5. And then we need to calculate B for the period. 2 pi over B equals pi. We'll multiply on both sides by B, obtaining pi times B. We'll divide both sides by pi, and we'll end up with B equals 2. So once I have all those things, I have A, B, C, and D. I'm ready to write my equation along with the base function here. And so we'll say y equals negative 1.5 sine 2 times x minus 0 minus 2.5. Questions? Okay. Step 1 is being able to follow and understand everything I'm doing. Okay. Step 2 is actually doing it yourself and finding it. That's going to be a little harder when we start on the delta method. So now I'm going to ask you some questions that ask you to use those things without even having a graph. Okay. Determine the minimum and maximum value of the following trigonometric functions. I like to sketch a graph. You don't have to. I'm just going to sketch a midline. This positive sign, so I know it's going to look like this, right? Midline is at negative 2. Max value is going to be the midline, and we're going to go up 10, and then we're going to go down 10, right? What's up?
I got that paper.
Which one? 2, 4? Are you sure that one got a name? It's not yours.
I do. I turned it. Yeah, it wasn't in my book. I know
I understand that like that is different. I get it, but I don't have it. I have everybody else. So.
Where's the one?
Where is it? It's in this one. Sure, I think that is.
I would not draw that one either.
It's not bad.
It's really bad.
It's got my-
I
I mean, it's in, if you want the paper, that's fine. If you want, it's in the classroom.
Oh, it's completely over the shower section.
Yeah, you just gotta write down the answers and stuff. You don't have to use scratch paper anyway. That sound good? You sure?
Like, just get a new one? Like what? You know, put it.
Do you want me to print you a paper, or do you want to just look at it in classroom? That's fine. No worries. Okay, I'm just making sure. Some people like to hold paper. Have a good weekend. Okay. Determine the minimum and maximum of the following trig functions. So are you tracking me when I'm saying that like the amplitude means we go up that many and down that many from the midline? So we're just going to say, negative 2 plus 10 to get the max, which is 8. And we're going to say negative 2 minus 10 is negative 12 to get the min. So max is 8, min is negative 12. Then, I'm going to come over here to the cosine, and you don't even really need these sketches if you don't like them, right? I just draw them just to get us used to looking at cosine. So cosine, this is negative cosine, so we're going to start down here and kind of do this. But this is just to give you a visual. So we're at 15 here at the midline, right? What's the amplitude? 5, right? So I'm going to go up 5, and I'm going to go down 5. So, this will be 15 plus 5, and this will be 15 minus 5. Max is 20. Minimum is 10. Done. Okay. I'm visual. I like to have a picture on these. If you're struggling, I'll ask you to sketch a picture. Yes,
I thought cosine started at its highest point, so
it does. But this is negative cosine. So it's a great question. That's a great question. It's reflected. So at this one, it's cosine is going to start at a max or a min, depending on the reflection. And cosine is going to start at the midline in both cases and go up. And if it's negative reflected, it's going to go down instead. Okay. All right. Determine the period of the following trigonometric functions. It's the coefficient of x inside the argument, which is the parentheses. What's that?
Because cosine started at like -1, was that change? I think I may have got it wrong because I got max 19.
How did you get max 19?
Because when you the mid
You're good.
line,
Because if we're at 15 here, up 5 is 20. And down 5 is 5, regardless of where the midline is.
okay.
Because this is, right? Does that make sense?
Yeah. Does the end point? Wait, what were you trying to?
I'm not talking about coordinates, right? Like, I mean, I guess I am talking about coordinates. Just start at 15.
Even though it starts like below 15.
Right, but the amplitude and the min and max are defined from the midline. Does that make sense? So just don't overcomplicate it. I see what you're saying. Your brain is thinking too hard about it, which is not a bad thing. But if you want to like look at it in Desmos to get a better handle on what's happening, I would suggest that. Right. All right. So we determine the period. The period is affected by B, which is 6/5 in this case. B is 8π/5 here, and it's 4π/5 here. It is the coefficient of x, regardless of if it has a pi or not. Sometimes it does, sometimes it doesn't. So B here is 6/5. B here is 4π/5. And B here is 8π/5. So determine the period. I'm going to call this one 1, this one 2, and this one 3, so I have room to work. So determine the period. Number 1, 2π over B, which is 6/5, equals the period. So, put this in your calculator. I think you're going to get 5π/3. Double check me, I did it in my head. 2π divided by 6/5. 5π/3?
Yeah.
Sweet. All right. Number 2. 2π divided by B, which is 8π/5, is going to give me the period. The relation never changes. You either have the period or you have B, and you just have to know which one you got. The equation has B. The picture has the period. Okay. So this one should be 10/4, 5/2.
It's 5/2.
You might be on number 3. You might be ahead of us. All right, so for this one, I have 2π divided by 4π/5 gives me the period. So that would be 10/4, which is 10/4. Hold on. Watch what I do when I get confused. I write something down. Let's see. This would be flipped over. This would be 2π. I don't have a calculator, so that'd be 10/8. It is 5/4 on this one. Good job. That's why I asked y'all to double check me. I'm doing it in my head. I'll write this one down. Cool. This would be 2π. Divide, you would multiply by the reciprocal. Y'all should be doing this in your calculator. I just don't have one. This one's 10/4, so that's 5/2. So this one's 5/2. Do y'all have to do any of these little calculations right here? Y'all got to do any of this? Why am I doing it? Because I don't have a calculator. And it's just easier for me to do it that way. So, very cool. So y'all don't have to do any of that. That just comes out of your calculator. Notice how sometimes the period has pi and sometimes it doesn't. And sometimes B has pi and sometimes it doesn't. That's perfectly normal. Okay. These are always radians, but not all radian values can be expressed in terms of pi. Some radian values is just 5 radians. Because remember, pi is just 3.14 roughly. So like, say again? Yeah. What is it, baby?
Oh, sorry, it's for baby.
Hey, what does it say in the letter to do?
Was it you or?
Hello. Only. Letters only. No, don't worry. You're fine. I'm just happy you're turning your stuff in. She's on J1, okay?
Thank you.
You're so welcome. All right. Example 7. Write a sine function. I give you the characteristics. You have to do the rest. Write a sine function that has an amplitude of 5, a midline of y equals 3, a phase shift left pi over 4, and a period of 3 pi over 7. So 2 pi over b equals 3 pi over 7. Notice I'm given the period now and I'm solving for b, which is the reverse of what I did in the previous example. So this would be 2 pi equals 3 pi over 7b. Divide both sides by 3 pi over 7. Gross. I can't do that one in my head. Hold on. So this would be 2 pi times 7 over 3 pi equals b. So that's going to go away. 14 over 3. And from this stage, it's pretty simple, right? We just go plug in A, B, C, and D. Remember, the general format is like this. It's A sine B x minus C plus D. So I'll say, all right, 5 sine 14 over 3. X minus negative pi over 4 is going to be plus pi over 4 plus 3. I know. All right, one more, and then I'm going to let you work. Write a cosine function that has amplitude 4, midline negative 7, phase shift right pi over 2, reflection across the x-axis, and a period of 7 pi over 2. So I'm going to say, all right, 2 pi over b equals 7 pi over 2. So I'll have 2 pi equals 7 pi over 2 times b. We'll divide by 7 pi over 2, so I'll have 2 pi times 2 over 7 pi equals b. That's going to cancel 4 over 7.
Yep.
Sweet. All right, here we go. Negative 4 cosine 4 over 7 x minus pi over 2 minus 7. Yeah. Yeah, it's like I like them. I like it. They're like little puzzles. It's a lot of information though, y'all. But this is the last new material that we'll have prior to. We have another quiz. So we'll review, quiz, review, test. That's what next week looks like so far. Okay. But you do have practice today, which looks like a delta math. So that's what we're doing right now. Okay. Get you some practice. If you need to sketch something, do that. It's helpful. This, I'll tell you where your problems are going to occur historically for students. It's finding the features from the graph and then the mistakes you're gonna make here is you're not gonna put this in parentheses and you should. The x minus c has to be in parentheses. You're gonna try to put the period here. The period does not go here, b does. The period is related by this. 2 pi over b equals the period that you see in the graph. You have to solve for b. And the other thing you're gonna miss is you're gonna miss that negative in the front reflected in the equation. Okay? So pay close attention. So again, the first step here is, can you follow what I am doing? The second step is, can you do what I am doing, right? So those are different things. You should not expect yourself to, just because you're looking at it and rocking and rolling with it, to then immediately jump over and have the same ease of doing it yourself. You will struggle for a minute, and if you don't, that's awesome. But you should not be upset if you're like, oh, this is way harder. Okay? You should just try and or ask questions. Let me push this out to you guys. I don't have it out yet because I don't want y'all working on it until I'm done. CYU number 2.